So let's start lecture 11, and in lecture 11 I am going to explain some very important graphs for distance time. For example, if this is your distance axis and this is your time axis and your graph looks like this, then one thing is very sure, motion is there, right? As I said in the beginning, your first question should be motion is there or not. Next question, if motion is there, then it is uniform or it is non-uniform, right? Okay. So first you have to check motion is there or not. After that, uniform or non-uniform motion. Now you have to understand, if motion is uniform, then you must get velocity constant. Okay, it means acceleration 0. How do you know your acceleration is 0? How do you know your velocity is constant? For all these things, if you are watching this lecture from lecture 1 of the series, then of course you will be having idea. If velocity is constant, then time term will not appear in the velocity equation. Time will not be depending on time. Sorry, velocity will not be depending on time. Speed will not be depending on time. It will be only a constant number. But if your velocity depends on time, then we can differentiate velocity one more time with dv by dt. In that case, I'll be getting acceleration. Okay, but if my velocity is constant, and then if you differentiate dv by dt, then it is going to be 0. What does it mean? In case of uniform motion, your acceleration will be 0, right? You see this curve. Let's analyze this curve, because as I said, we are going to analyze all 4 important curves of this lecture, like one this one, one this one, one this one, one this one. These type of curves we are going to understand. So now you see, I am starting from here. So in this curve, you have see here, first of all, at this point, if you draw the tangent, okay, you draw the tangent, then at this point you draw the tangent. You can see when you are moving in this direction, because time always increases in this direction, so this is going to be your point 1 and this is going to be your point 2. Okay, so you are going in this direction. So at point 1, when you are finding out the tangent, then you are going to have this angle theta, right? So you say theta 1, this angle is theta 1, and when you are bothering out the second tangent is making theta 2 angle. You can clearly see theta 2 angle is more than theta 1 angle. It means what? With theta 2, if you will find out slope, that is nothing but tan theta 2, and with this tan theta 1, if you find out slope, that is nothing but tan theta 1. So because theta 2 is more than theta 1, so automatically your tan theta 2 will come greater than tan theta 1. If you did not understand this, no problem. In mathematics, these kind of doubts will be okay. And as I said, next year I'm going to start for 2023 batch complete class. So if you are interested, you can text me on WhatsApp number, you can find in description, and you can join my classroom program. And fees will be very minimum. Whatever you are paying in your nearby area in offline centers, very less than that. So that an intention to run a separate batch for IIT JEE and NEET, so that you can ask me live doubts in the classroom. Classes will be on Zoom app. So understand this tan theta 2 and tan theta 1 value. So tan theta 2 will be less than tan theta 1 value. It means this slope will be less than this slope. It means slope of, now see, slope of ST graph is nothing but velocity. Okay, so this slope is less, this slope is more. It means when you are going in this direction, then your velocity is increasing, correct? If your velocity is increasing, then definitely you have acceleration. So these kind of curves will represent non-uniform motion. Okay, I hope it's totally clear. So if you have non-uniform motion, then your velocity will not be constant. It will definitely change with time. And if velocity is changing, then definitely acceleration will not be 0. So these are the ideas to judge non-uniform motion. I hope it's totally fine, right? Okay, now imagine if what are the extra things you can judge in this. So see, actually in this diagram, if the same diagram will come for VT graph, that I will explain when I will be explaining VT graph. Right now in this diagram, some students may think that when they are coming, suppose they are saying that this point is 0.1 and this point is 0.2, so they want to come like this. Actually see guys, time axis is this, so in this direction you cannot come. Time never flows back, right? So you should never consider in this way, you should always consider in this way. So this will be your first position, this will be your second position. So at first position, whatever is your tangent, at second position, whatever is your tangent, so tangent will give you slope. Okay, one more thing I should clear here itself, because some biology students will be watching this video. So immediately you see here, if you have any curve like this, at this point if you are drawing the tangent, then this tangent will make any angle theta, so then you will find out tan theta. So this total quantity tan theta, this thing is known as slope. Okay, now you know that this is mathematical model. Okay, clear? Now if this is your st axis, then the same slope which is tan theta you will represent with ds by dt. If this is your vt, I mean velocity time axis, then the same slope tan theta you will represent with dv by dt. Okay, but right now we are doing our distance time graph. So in case of distance time graph, at this point if I am drawing the slope, then this is going to make theta 1. At this point I am drawing the slope, I mean tangent, then this is going to make angle theta 2. So see guys, here we have three names. One thing is tangent, one thing is angle, and one thing is slope. Okay, and all these things we are drawing for a curve. Okay, so four things are there. Okay, you can also consider there is something called axis also. So see, this is your axis, this is your axis. Axis part is clear. Okay, now next part, curve part. So this curve line you can see, this is the curve line. Then tangent part, so this is straight line and this is straight line. This is tangent part. Angle part, so this is angle, this is angle. And then what is slope? Using angle you will find out tan theta. That new quantity we call as slope. Now it depends. Your slope can represent velocity also, it can represent acceleration also, right? It means this tan theta what you are finding out, either it is going to be ds by dt, which is nothing but velocity, or it is going to be dv by dt. This means acceleration, correct? But right now I am teaching you distance time graph, so this will be my slope, right? So this is what I was saying. If your curve is going like this, so at this point you will find out slope, then at this point you will find out slope, at this point find out slope, at this point find out slope. So because your angle is continuously increasing, then slope is continuously increasing. So because it is distance time graph, so your slope is nothing but velocity, so your velocity is continuously increasing, right? If velocity increases, it means you have acceleration, right? Totally going well. Okay, so now we have done this curve, this curve, this curve, this curve, and now this curve is also done. Now let's, so I hope you understood what is the meaning of this. Now in this curve your velocity is not constant, I mean in this curve your velocity is continuously increasing. So what kind of sound you will make? You will make like this. Okay, but if your velocity is constant, in that case how will you make sound? Then it will go constant sound. Suppose this is your constant straight line. In st graph this is a straight line, so straight line will decide what? A straight line will tell you velocity is equal to constant, right? Because your slope is constant. At this point you draw tangent, it will be same line. At this point you draw tangent, it will be same line. At this point draw tangent, same line. It means everywhere you will be having same slope. Same slope means same velocity everywhere. If velocity is same, it means velocity is constant, and if velocity is constant, it means acceleration is zero, correct? For constant velocity, what kind of sound you should make? You should make a sound like this, like vehicle or bike or car will make this kind of sound. I mean constantly going. It will not increase like or it will not decrease like no, right? So v is equal to constant and acceleration is equal to 0. So this is the idea behind your ST graph. Now suppose you have this kind of graph, now in this case you can clearly see your distance is, when time is increasing, it is like umbrella type. I will draw again. It is like umbrella type. Okay, what does it mean? It means when time is increasing, so you can see in the beginning when time was suppose 1 second, that time you came to graph, you had this much distance traveled. But when time was 2 second, like 2 second, then you had this much distance traveled. But when time was 3 second, that time you had this much distance traveled. Means you can clearly see the gap is continuously decreasing, correct? It means what? Earlier your vehicle was faster, that's why it was traveling more distance. But now your vehicle is being slower, that's why it is covering less distance. Then again vehicle is being more slower. Suppose at t is equal to 4, at t is equal to 5, at t is equal to 6. So you can clearly see t is equal to 4, you are going here. T is equal to 5 also you are going here. T is equal to 6 also you are going very much closer. Constantly your length is decreasing. It means what? Your vehicle is being slow. It means, right now you understand, when you are finding out, so one thing is clear, that motion is there. It is uniform motion? No, it is non-uniform motion. Why? Because velocity is decreasing. How velocity is decreasing? Because in the first second distance covered was more, in the next second distance covered was less, in next second distance covered was less, in next second further less, right? So it means what? Vehicle is being slowed down. It means what? Brakes are applied, right? It means what? There is a term called acceleration and opposite term is retardation. Retardation means your velocity will decrease. Retardation is also known as negative acceleration. Negative acceleration means again your velocity will decrease, right? Okay, so you understood what is the meaning of this graph? In this graph motion is there? Yes, motion is there. Which graph is this? This is ST graph. Okay, distance time graph. Okay, now you can see suppose I'm drawing this kind of graph, and after that totally straight, fully straight. It means what? Till from 0 time to this time t, your vehicle was being slowed down. After that vehicle stopped completely. After that your distance is not increasing. You can see distance is not increasing. Whatever was the final distance, this was the final distance. After that only time is increasing. So till here you had motion. After that here no motion. I hope it's clear, right? Based on this you can think about your slope also. How will you think about slope? You think about slope in this way. At this point if you draw the slope, that will be this angle. At this point if you draw the slope, that will be this angle. So you can clearly see the first angle theta 1 is more than theta 2. It means what? Now if you're going in time direction, your slope is decreasing. It means what? Slope is decreasing means which one is decreasing? In ST graph, slope means what? Slope means velocity. Velocity is decreasing. Velocity decreasing means what? Acceleration is negative. That is known as retardation. Okay, so I hope it's very clear. It means slowly you are understanding the graph, and if you are really understanding the graph, just comment in the box whatever you want to comment about the lecture. Just comment. Let's go ahead.